the two main types of math questions they like to ask are factor labeling, crossing out units, changing units, and percentage problems. A sanitary landfill has a surface area of 6,000 square meters, receives a yearly rainfall of about 300 millimeters. 20% of this precipitation is runoff, so it does not go into the landfill. A leachate, remember that's the garbage juice, a leachate collection system is installed under the landfill. It is 90% effective. It's the volume of leachate in meters cubed that they can treat per year. All right, the first thing we need to do is figure out volume, which you see we've got meters squared, that's area, and we have millimeters. So if we multiply those together, that's going to give us the volume of rain that enters the landfill. So the first thing we have to do is change 300 millimeters into meters. Well, that's 3 steps on the metric staircase. There are 1,000 millimeters in a meter. And so I'm going to move 3 to the left. If I go up the stairs, 1, 2, 3. So that becomes 0.3 meters. That's how much rain they get each year. All right, so if I take 6,000 square meters times 0.3 meters, that's the amount of rainfall. Don't even worry about what the answer is yet. I'm just going through the method. So the next thing we have to do is about 20% of it runs off. So we have to subtract that 20%. Instead, what I'm going to do is just calculate 80%, the remaining. So what is 80% of the volume of rain we just collected? Well, to solve that, you multiply by 0.8, right? A percentage, you move it 2 decimal places to the left. So multiply your first answer by 0.8. That's how much water goes into the landfill. And the last step is we see it's 90% effective. So I need to multiply it again by 0.9. The answer ends up being B. And there is the answer spelled out for you with the numbers. All right. New material. So we're still talking about pollution, toxins, but for the next 2 weeks, we're going to focus just on one branch of pollution, and that is water pollution. On the top left there, you see a picture of gorgeous, beautiful Cleveland, Ohio. Cleveland is notorious for being a kind of a dirty, gross industrial city. They've tried really hard over the years to make it more attractive. They've built new sports stadiums. They built and put the Rock and Roll Hall of Fame there. But anyway, in the late 1960s, you see that river running up through the town there and how gross and dark it is? That's called the Cuyahoga River. It caught on fire. And that got people's attention. How does a river catch on fire? It caught on fire because all these industries were pouring nasty chemicals into it. So after that incident, people started waking up, and it's when all these environmental laws came out, 1970s. You see that the federal government wrote the Clean Water Act. And this one directly went after factories, industrial facilities, sewage treatment plants, which we'll talk all about next week. All this stuff was given regulations, limits on what they could throw in to the local water sources. Now, this act does not talk about our drinking water and our aquifers. It's really only talking about surface water. You can see today, the river is a normal color, and Lake Erie is a relatively normal color. Much improvements have been made. Of all the Great Lakes, Lake Erie is probably still the dirtiest, nastiest. That's because you got cities like Cleveland, Detroit, which all dumped nasty stuff in there. Okay, so once again, topic today, water pollution. Now, the first couple slides I'm going to go through today are things we already learned. So this is review. What are some things that get in the water that are problems? We talked about microbeads and plastic waste that ends up in the ocean. Remember that everything is connected. It's called a watershed. when it rains in the parking lot at North Central, some of that material ends up in the Gulf of Mexico. Remember that the fashion industry is actually one of the worst because all of these synthetic fabrics we make, when we wash them, little plastic microfibers come off in the laundry and go down the drain. Car tires, right? Tires wear out over time. And that a lot of that rubber ends up on the street, which goes down into the sewers, which goes to the watershed. We talked about the great garbage patch in the Pacific and the fact that we sent a whole bunch of our recycling to another country and they are overwhelmed. Acid mine drainage, sulfur. Remember, that's the main ingredient. Sulfur gets in the water and can run off. Heavy metals, which we just learned about not too long ago, mercury and lead. Remember, those bioaccumulate. They build up in the aquatic organisms. And then as we eat those, the levels become toxic, TD50. So it gets magnified up the food chain. Waterborne disease, so bacteria, viruses. We talked about dysentery, cholera, unsanitary conditions. When sewage treatment plants get overwhelmed from flooding, sometimes they have to release untreated sewage into the water systems. You can see signs that are put up when this happens. Swimming area closed due to elevated levels of bacteria. We talked about runoff from CAFOs. All that cattle produces really nasty runoff that can cause all kinds of nasty problems in water sources. Industrial water pollution, so POPs, all those nasty chemicals, PCBs. Another one I would include in this is oil, right? Oil is a hydrocarbon, it's organic, petroleum-based, and it's persistent unless we clean it up. So here you see after Hurricane Katrina, big one that hit down in New Orleans, early 2000s. That water, you see the shine on it? That's gasoline and oil that is leaked out, floating on the top of that water. You can see the beaches are closed after oil spills. How about something new? We're going to focus on today and tomorrow when I take you guys outside, Friday for you Black Day folks. We're going to look at how sediment can be considered a pollutant in the water. This is right out of the AP guide. You can see that when we have sediment in the water, obviously it changes the color of it, but it can reduce light infiltration. So your organisms that grow on the bottom of the water source, they're making dissolved oxygen through photosynthesis, but that's not happening if there's too much sediment in the water. That can affect the whole food chain. Primary producers, animals that rely on their site, and obviously sediment buildup can completely move a habitat. I'm going to take you out by the creek tomorrow and we're going to look at this process of erosion and deposition. When streams get down to what's called base level, they stop cutting down, they start cutting side to side. We call this a meander. Kind of just go wherever they want. And we've been battling rivers now for years. The Mississippi, we continually build what are called levees to try to make the river go where we want. And every couple of years, a huge flood comes along and shows us who's really boss. So we usually lose the battle when it comes to rivers. But what's neat about rivers is we know they carry lots of sediment. This is, you can see what's called a confluence. The river on the left is meeting with the river on the right. And you can see this one already had a lot of sediment. And so the mixture happens at the confluence. But they can deposit that sediment. There's usually 3 times they deposit that sediment. The first one is if they slow down, right? It's like carrying a whole bunch of groceries in. If you don't do it fast enough, your arms get tired and you got to put them down. So rivers slow down for a number of reasons. One of them is if the river gets narrower, it actually speeds up. But then when it widens, it slows back down. It's the whole putting your thumb over the hose. You can speed it up if you narrow it and slow it down if you widen it. The second way it drops has to do with speed also. And that's when it goes around a curve. This is the old, if you're marching in a straight line in a parade and you go around a corner, the person in the middle is going really, really slow. They're called the point. And the person on the outside has to swing around really far. They're moving faster. Water does that. And so on the outside of the curve, it cuts. That's called erosion, weathering and erosion. It cuts away. And that means on the inside of the curve where it's moving slow, it drops some of the sediment. And we can see this clear as day out at the creek in the cross-country woods. So I'll show you that tomorrow. The third way that rivers deposit their sediment is when they stop, when they get to the end, the Gulf of Mexico. That's called a delta, a big triangular shaped sediment deposit. All of the tip of Louisiana was put there because the river entered a larger body of water. We experienced this right here in Indianapolis. Look how the White River meanders back and forth all the way down into Broad Ripple. And if you drive down Westfield and you get around that big curve there, if you look off to the left, you'll see a huge cement wall that's actually holding the river back. We're trying to control where that river goes. Our city engineers have stopped it from doing more erosion on the outside of that curve. We talk about the muddy Mississippi. Have you ever heard that? The Mississippi River is gross, brown, ugly. That's because it's the biggest river. It's got all the sediment in it. And here you can see a construction site. It produces lots of tiny little dirt and dust. Some of that goes into the air. And when it rains, it goes down our drains. They usually do a very poor job of containing the runoff.